this lecture, we are going to take a look at converting between the metric system and the US standard system. What is a metric system, conversions within it, and how we do conversions within it, and then conversions within the US standard system itself. Now, usually when we start off this lecture, my students have a lot of questions, and most of them are along the lines of, why do we care? Because we don't use any metric system in the US, and the rest of the world is basically closed to US travel right now, so who cares? Why does it matter? So why does it matter? Isn't this what that Hamilton musical is about? The reason why it matters is because in the US, while everything is measured in imperial system, we use the metric system for dosing and for medication. Go ahead, pause the video, go run to your bathroom, see what kind of drugs you can find in there. Please don't tell me what you found. See if you can find like a bottle of ibuprofen or a bottle of cough syrup, and look at the label. The label probably has the drug measured out in milligrams or in milliliters, not in teaspoons or tablespoons or ounces. And this is why it matters that you understand the imperial system and the metric system very, very well, because it's very easy to overdose your patient if you're not paying attention to your labels on the medication. For example, let's say you have a baby, and your baby came in with an ear infection, and the baby gets prescribed 5 milliliters of amoxicillin POTID. And this POTID, this is something that you will see a great deal in the future. PO means per os. This is by mouth. So an oral medication. TID means 3 times per day. CHIMD, 3 times per day. Okay, so our baby's getting 5 mils of amoxicillin 3 times per day. Let's say, though, something goes terribly wrong while you're printing up the label, and the label that you stick on that bottle of amoxicillin is 5 teaspoons per os CHIMD. Well, there's still 5, right? What's the issue here? Milliliters versus teaspoons. How many milliliters are in a teaspoon? 1 teaspoon is 5 milliliters. So if our baby is supposed to get 5 milliliters or 1 teaspoon, and somebody screwed up on the printer and now our baby's getting 5 teaspoons per dose, how many milliliters is our baby getting in each dose with that 5 teaspoons? Our baby's getting 25 milliliters, 5 times what they were supposed to get. And 3 times a day, that baby should be getting 15 milliliters total in the whole day. Here we've gone over the dosage in just the daily dosage in just 1 dose. And our baby's going to be getting 75 milliliters per day. That's a lot of amoxicillin for a very small baby. So this is why we go over metric versus standard, because mistakes like this are incredibly common. And it's very important to make sure that you understand the difference between metric and imperial so that you don't wind up doing this and overdosing your patient. So let's look at a little comparison between the imperial system and the metric system, and then we'll take a look at the metric system in more detail. So we have different units of measure for both imperial and metric. We'll start with imperial, and we have different units of measure based on what we're measuring, mass, length, or volume. For the imperial system, if we're measuring mass or weight, we're usually going to use pounds. And if you go to the doctor, they throw you on the scale, the readout will print out in pounds. If we have something that's a little less than a pound that we would want to weigh out, or we want to be very specific, we'd use ounces. Those of you who have had a baby, you know that when that baby comes, they tell you the baby's weight in ounces and pounds, right? Baby weighs 6 pounds and 10 ounces. Tons is a whole bunch of pounds. Tons is 2,000 pounds. So we would use this to weigh something like your car. Length, we use feet. You go to the doctor and they take your height, they'll measure it in feet, usually feet and inches. How many feet are in a mile? Take a minute and try and figure that out. This was the Mile High City long before we legalized weed. So 5,280 feet in a mile, and then 3 feet in a yard. And then for volume, we usually measure volume using gallons. Think about buying gasoline, for example. But you can also buy volumes of stuff in smaller things. 4 quarts in a gallon, if you buy like a quart of milk at the store. 2 pints in a quart, 2 cups in a pint, and then tablespoons and teaspoons like we saw earlier. You know, if you bake or cook a lot, you're very familiar with those. When we look at these 3, mass, length, and volume, using the metric system, we see that they operate around a base unit. This is not a concept that we have in the imperial system. The closest we could come to a base unit in the imperial system would be something like pounds and feet and gallons. That's sort of your go-to measurement in the imperial system. In the metric system, our base unit for mass is the gram, and this weighs about as much as a large paperclip. For length, it's the meter. A meter is approximately a yard. It's about 39 inches. And then our base unit for volume is the liter, which is about a quart. It's about 1/4 of a gallon, give or take. Again, we don't have this concept of a base unit in the imperial system, but this base unit makes things so much easier. And we'll see how and why in a little bit. So let's look specifically at the metric system. Like I said, we have our base unit, our meter, gram, or liter, depending on whether you're weighing mass, length, or volume. And prefixes are used to denote greater or smaller units of measurement with the metric system. You maybe have heard of kilometers or millimeters or kilograms or milligrams, for example. If we were going to measure something that had very small length, like say your phone, we would use a millimeter. We'd use very small units of measure, something even smaller than a meter. And that prefix milli tells us that we're measuring something very small. If we were going to measure something of very great length, very far length, we would use kilometer. Maybe you say, screw this, I'm done with Colorado during the pandemic, and you decide you're going to go spend the rest of your time at Bahia Honda State Park until everything opens back up. You're going to go drive down to the Florida Keys. We would measure that distance in kilometers. It would not make any sense to measure it out in millimeters. It wouldn't even make sense to measure it in meters. You'd wind up with this infinitely long number. So these prefixes, like I said, denote the value that we've moved away from our base unit. In our little table here, anything above our base unit, kilo, hecto, or deca, this is greater than our base unit. A kilometer is worth more than a meter. On the other hand, if we have something down here, these guys, these are less than our base unit. So deci, centi, milli, and micro. These are all smaller than our base unit. A milligram is lighter in weight than a gram, or a millimeter is shorter than a meter. The value here indicates how many of this goes into a gram. So if we look over here for kilo, kilo has a value of 1,000 because there are 1,000 grams in 1 kilogram, or 1,000 meters in a kilometer, or 1,000 liters in a kiloliter. There are 100 grams in a hectogram, 10 grams in a decagram. And then from here, going down to our smaller units, deci, centi, milli, and micro, we have smaller units of measure. So we have here for a deci, there are 10 deciliters, we could say, in 1 liter. Or for centi, there are 100 centiliters in 1 liter. For milliliter, that would be 1,000 milliliters in 1 liter. And then for micro is a million. So for micro, there would be 1,000,000 microliters in 1 liter. And hopefully you notice in this value column here, these are all base units of 10, multiples of 10, right? 10 times 1 gives us 10, 10 times 10 gives us 100, 10 times 100 gives us 1,000, and so on when we go down to our smaller units of measure. And this operation around base 10 that we see in the metric system is what makes it ultimately a whole lot more user-friendly than the US imperial system, much more user-friendly than the imperial system. Now, the other way that you can think about the metric system, and this is the way that I really like, this works very well if you're a very visual learner, is this little stair-step chart or table right here that places all of our prefixes and their values in positions around our base unit, meter, gram, or liter. I really like this chart because if you get comfortable with it and if you memorize it, if you're able to either write it out quickly or see it in your head, it makes it very easy to convert back and forth between your units of measurement without a lot of thought. Again, going back to that base unit, going back to the base 10 that I mentioned in the previous slide with the metric system, because the metric system is base 10, because it's based off of multiplying or dividing by units of 10, our numbers never actually change. If you think about converting with the imperial system, you have to know all kinds of numbers. You have to know that there are 4 quarts in a gallon, and that there are 12 inches in a foot, and that there are 5,280 feet in a mile, and that there are 16 ounces in a pound. The metric system, the equivalent of that would be like saying that there are 10 inches in a foot, and 10 feet in a yard, and 10 yards in a mile. It would be something much simpler like that. So let's look at this little chart in action then. Let's say I have, 3,500 milligrams of something. And 3,500 is a very big number, and I want to make this a little easier to work with. I want to talk about this not as milligrams, but as grams, and make this number a little less big. How do I convert milligrams to grams and get that smaller number? Well, the easiest way to do it, the way I like to think of it, is to use our little stair-step chart. And we start by finding what place value are we in, what prefix do we start with? Right here with our milligrams, we're starting with milli. That's where we are. So find our milli on our stair-step chart, and milli is all the way down here, down at the bottom. Milli is 1,000, so there are 1,000 milligrams in 1 gram. So that's where we are. Where do we want to end? Where do we want to go or convert to? Well, we want to convert to grams. This is where we want to be. We'll go ahead and find gram on our stair-step chart, and that's right here. Here's our base unit right there, meter or gram or liter. Okay, so if we want to go from milli to gram to our base unit, all we have to do is climb our stairs. And we're going to move up 1, 2, 3 steps from milli to gram, and we're going to go up to the left, 3 steps to the left. That means that our decimal in 3,500, which is hanging out back here, not doing anything, just kind of chilling, our decimal is going to move 1, 2, 3 steps to the left as well. We'll drop him there at our new position, and that's going to give us 3.5 grams. Essentially, if you're interested in the more technical mathematical details here, what we did is we divided 3,500 by 10 3 times. And if you want to try that on your calculator, you can. Just pull out your calculator, plug in 3,500, divide it by 10 once, and then by 10 again, and then by 10 a third time. because each time that we move up to the left, we're essentially dividing by 10. But if you don't like to think about the technical details behind it, I find that thinking about your chart is much, much easier. Let's look at another example. Let's say we have 2,786, I don't know, liters of something. You're like that guy that was hoarding hand sanitizer in his garage. And you want to convert that to kiloliters. Because 2,786 is a big number, it can be a little unwieldy to deal with. Well, we're starting with liters. Oh, and as a short side note, liters is always written abbreviated with a capital L, because if you write it lowercase l, then it looks like a 1, and you're not sure what you're writing, so always write liters as a capital L. So we're starting at liters. We have 2,786 liters. So go ahead and find liters on our little stair-step chart, and that's in this position right here, our base unit. There's our liter. We want to go to kiloliters. There's our kilo, and here's our kilo up here on our chart. So if we're going to go from liters to kilo, which direction are we going, and how many steps is it going to take to get from liter to kilo? We're going to go up 1, 2, 3 steps, and we're going up again to the left, which means that our decimal at the end of this 2,786 is also going to go 1, 2, 3 steps over to the left. We'll drop it there so that we get 2.786 kiloliters. Now, hopefully in these first 2 examples, something that has stuck out to you is that our numbers have not changed. If you think back to when we were talking about US standard system, and I told you 1 mile is 5,280 feet, right? Our numbers in our metric conversions haven't changed because they are multiplied or divided by 10. This is a benefit of having our numbers in a base unit of 10. The actual place value of the decimal changes, and that's what changes the value of the number. But we didn't go from 2,786 to something like 10,000, like we would in the US standard system. So if you are doing your metric conversions in your homework, and you go from a number that has 2786 to a number that has 5794, go back, because something is wrong. Your number should never change. The only thing that changes is where our decimal started and where our decimal ended. Let's look at a few more examples. And before we do that, I want to draw in one last little piece of our puzzle here, and that is 3 steps down from milli, we have our micro. You remember him from a few slides ago. Micro is abbreviated MC, sorry, not MCG. MCG is micrograms. Micro is abbreviated MC. Milli is abbreviated M. Or you'll sometimes see the very old school medical professional will abbreviate it the Greek letter mu. This is falling out of favor mostly because nobody knows how to write the Greek letter mu, myself included. So micro is generally abbreviated MC. So let's say we had, I don't know, 1.5 grams of medication. And someone comes to you and says, hey, I need you to measure this out into micrograms. How many total micrograms of meds do we have? You're working in peds, and you need to have your drugs in very, very small doses. Well, we have 1.5 grams. That's where we're starting, right? Always figure out where you're starting first. So we're starting at our base unit with gram. We're going to go to micrograms. So we're going all the way down here to micro. So we're going to the right first, because we're going down to the right, and we're going how many steps? 1, 2, 3 steps to milli, and then 1, 2, 3 steps to micro. So 6 steps total to get from our base unit, from our gram to our micro. So that means our decimal in that 1.5 is going to move to the right 1, 2, 3, make sure you throw in some zeros, 4, 5, 6 times total. So we're going to get 1,500,000 micrograms of medication in our 1.5 grams that we have. Hopefully they're not going to make you sit there and measure out all of that medication. Let's do a few more. Let's say you're ordering more medication. They put you in charge of ordering drugs for the office. And they gave you the phone and the book and they said, have fun. And you put in an order for 0.0647 kilograms of, I don't know, remdesivir, treating a lot of COVID patients. You want to know how many grams of remdesivir have you ordered? Because kilograms doesn't really tell us much. We need that in grams. So go ahead, try to do this on your own. Pause the video and do it on your own. Think about where we're starting. We're starting at kilo. That's what we have. We want to go down to gram. That's where we're going. So how many steps is it going to take to get from kilo to gram? And what direction? Are we going left or right? So from kilo to gram, we're going to go down 1, 2, 3 steps, and we're traveling down to the right. So that means our decimal is going to go to the right 1, 2, 3 times. Drop your decimal in its new position, and we get 64.7. So your 0.0647 kilograms of medication is going to be 64.7 grams of remdesivir. Let's say you have a patient that is getting 1,500 milliliters of medication every day. And you want to know how many grams. Actually, you want to know how many centiliters of medication that is. This is going to be a pretty short, fast conversion. We're starting at milli, we're ending at centi. So we're starting here from milli to centi, which means we're going up 1 step. So which means our decimal is going to go, and our decimal, remember in a whole number, the decimal is always hiding at the back of the whole number right here. Right? 0.1500 is not the same as 1,500. Our decimal is back here at the end. And we went from milli to centi, which means we went 1 step up to the left, which means our decimal is going to do the same. It's going to move 1 step over to the left and give us 150 centiliters. One more example. Let's say you're going over to Beirut to help them after the gigantic explosion, and you have ordered a whole bunch of medication, and that medication comes written out in grams. You ordered a bunch of amoxicillin, and the chart that you place your order on says that you have 2,750,000 grams of amoxicillin. You are taken with you to Beirut. But in order to put that down for the flight register so they know what you're importing to the country, you have to write down how many kilograms of medication you are bringing with you to Lebanon. So, how many kilograms is 2,750,000 grams? Well, again, where are we starting? We're starting with grams. which is our base unit right here. Where are we ending? What are we converting to? We're converting to kilograms, which is this position right here, up at the top. So we're going from grams to kilograms. Again, how many steps and in what direction? So we're going up 1, 2, 3 steps to get from gram to kilo, and we're going 3 steps up to the left. So here's our decimal hanging out back here at the end. He's going to move over 1, 2, 3 steps to the left, and we'll drop him there. So that means you are bringing 2,750 kilograms of amoxicillin with you into the country. Good luck. Now, like I said earlier, this is a really handy little chart to have, to memorize, to be familiar with mentally. If the chart itself, if you want an easy way to remember it or an easy way to remember your place values, there's a handy little mnemonic for that, which is King Henry died drinking chocolate milk. Kilo, hecto, deca. Here is our base unit, either gram, meter, or liter. Deci, centi, milli. If you wanted, you could even throw in, I don't know, King Henry died drinking chocolate milk, Mom. And that little M down there could be your micro as well. So kilo, hecto, deca, deci, centi, milli, and micro. So that is metric system conversions in a nutshell. Big takeaways that you should have whenever you're converting something within the metric system are that, again, the numbers in your problem should not change. The only thing that should change is where your decimal is located in that number. Since I know that metric system is fairly new to most of my students, if you have questions about this topic or would like to go over it with me, or double check your homework even, drop by office hours or send me an email and we can go over it together. Now, if we look at converting back and forth between the metric system and the imperial system, this will be a little simpler because we're going to use a technique that you've seen already, that you've been doing for at least 2 days worth of homework now, and this is all going to be cross multiplication. So let's say you have a patient come in. This is you working in Beirut. You have a patient come in and your patient is 145 pounds. They get on the scale, or 47. They get on the scale and the scale says 147 pounds. But they don't use the imperial system in Lebanon. They use the metric system. So your patient wants to know, wait, how many kilograms is that? Well, you can't get the scale to read out in kilograms, unfortunately. But you do know, because you paid attention in math class, that 1 kilogram is roughly 2.2 pounds. So we can do this calculation pretty quickly. This 1 kilogram equals 2.2 pounds. We can just write that as a ratio. That's two unrelated things being compared using numbers. That's the ratio if ever I saw one. So 1 kilogram to 2.2 pounds. And then we can set that up as a proportion. Remember our proportions lecture? With 147 pounds, keep your labels together, pounds with pounds, kilograms with kilograms, and then we're not sure how many kilograms, but that's what we're going to find out. And then we will cross multiply this, just like with your ratios and proportions lecture. So we'll have 2.2 pounds times our mystery variable equals 1 times 147. 1 times 147 is just 147. And then remember, we're going to divide by whatever number is multiplied to our variable. So we'll have 147 divided by 2.2. And 147 divided by 2.2 will give us 66.81 repeating. So 66.81, 67 kilograms approximately is how much your patient weighs. Okay, now let's say they move you over to PEDS. You're working in the NICU in Beirut, and you have a baby come in, and that baby is 25 inches long. And you tell the parents that, and the parents probably tell you in Arabic, I have no idea what you're saying, and also how long is 25 inches? Well, 25 inches to centimeters, we know that 1 inch equals 2.54 centimeters. So again, we can write that as a fraction, as a ratio. 1 inch equals 2.54 centimeters, or 1 inch to 2.54 centimeters. Our baby's 25 inches long. Inches will stay with inches up on the top here. Centimeters with centimeters. We don't know how many centimeters long our baby is. That's what we're going to find out. And again, we will cross multiply to find out. So 2.54 times 25 equals 1 times our mystery variable. And 25 times 2.54 is 63.5. Obviously, we would divide by our 1 over here. Any number divided by 1 is itself. So 63.5 divided by 1 would be 63.5. So your 25-inch long baby is 63.5 centimeters long. Remember that 2,750 kilos of amoxicillin that you were going to bring into the airport? How many pounds of that are you bringing? You have to declare that on customs in order to get it to leave the U.S. Well, again, if we know that 1 kilo is 2.2 pounds, and we have 2,750 kilograms of medication, and we want to know how many pounds of meds are you taking with you to Beirut. Well, we can cross multiply this, and we'll get 2.2 times 2750 equals 1 times our mystery variable. And then 2.2 times 2750 is 6,050. Specifically 6,050 pounds. You're taking a whole lot of drugs with you to Lebanon. We can use the same technique to do conversions within the imperial system as well. So let's say you get home from your stint in Beirut with, I don't know, Doctors Without Borders, and you decide you need a vacation, you need a break after that. So you are going to go down to the Florida Keys and camp out on Bahia Honda Beach for a while. So you are going to drive from Denver to Marathon Island. And it's approximately 2,500 miles from here to Marathon Island, down in the Florida Keys. And for whatever reason, you want to know how many feet is that from here to Marathon Island. You have a lot of time to kill on the plane ride home from Beirut. So we know that 1 mile is 5,280 feet. We can set up a pretty easy conversion and find out how many feet it is from here to Marathon Island. We got 2,500 miles. We don't know how many feet it is, and we're not sure why we want to know, but we're going to do it anyway. Cross multiply will give us 2,500 times 5,280 equals 1 times our mystery variable. 2,500 times 5,280 is a lot, 13,200,000 feet. Obviously, we would divide by the number multiplied to our variable. In this case, that's 1, so nothing's going to change in our number here. So this is how you would go back and forth doing conversions between different units in the imperial system or between imperial to metric system units. The conversions that you'll need, stuff like this guy up here, 1 mile equals 5,280 feet, you will find that in the second page of the math section of your textbook. I will also post a list of conversions that you'll need at the top of Blackboard, so you'll have those available in the folder where this lecture is, so that you can use them. You won't have to go hunting for them across the internet. So that is out for conversions and for your introduction to the metric system. As always, if you have questions or if you would like to double check your homework, shoot me an email, drop by office hours, or text, and we can go over your homework and your problems together.